Hey guys, Mr. Middleton here. Today we're going to look at interpreting graphs, starting our third unit of relations and functions. Okay, at the end of this video you should be able to interpret graphs by describing what is happening at each section of the graph, and you should be able to analyze situations and sketch graphs that represent the given situation. Alright, so here we go. Start. Each graph has two axes. An x-axis goes horizontal and a y-axis that goes vertical. Vertical. I hope it's this way. Okay. Each has a label, and it's important to know what they're actually measuring. Okay, and so that's why they're labeled. Typically, the x-axis is labeled time. It can be labeled other things, but normally it's labeled time. Okay. X-axis is the independent. I guess I should write these here. X-axis is usually the independent variable. Independent. Y-axis is the dependent variable. More of a science term, but make sure you guys see that. Okay. Let's look at this example and go through the problem. So we have this graph here. And what is the graph showing? It's showing the altitude of a plane over time. You'll notice that we're getting these words basically by looking at the labels of the graph. The y-axis is measuring altitude, x-axis is measuring time. Where is the plane at its highest point? Well, we see the highest altitude here. We can find altitude. Where is it highest? The cruising altitude. Okay. Number 3 is, where is the plane going the fastest? Now I know that people want to answer this question, but realize this graph doesn't give us enough information. The graph does not measure speed. So this graph doesn't measure speed, so we don't know. Not enough information. I'll just say NEI, not enough information. Okay, all it tells us is how high it is. Is it going really fast? Is it like going slow? I don't know. Okay, and what does the flat portion of this graph represent? Well, when this graph is flat, it shows that it's a constant altitude. Okay, it's not going up anymore, it's not going down anymore. The altitude's staying the same. Okay, and that's just us being able to use the labels and read what's happening in the graph or interpret what's happening in the graph to answer these questions. Okay, let's look at the next example. Again, using this graph, what is the graph showing? So we have total distance, we have time, we have a commute home. So it looks like it's just showing how far the distance for a person's walk home. Okay. Where is the person going the fastest? And how do we know? Okay, now we can tell when the person's going the fastest, in this case, even though it's not really measuring it, we're measuring distance. And so we see this distance is coming, this distance stays the same. This distance. When the person is on the bus or taking the bus. Okay, and we know this because this is where the line rises the fastest or the most or the steepest. Let's say the steepest. Okay, that increase from this distance to this distance happens the most here. Okay, and that's how we can tell, or the fastest here, and that's how we can tell that that's where it's moving the fastest, the distance that he's traveled. What does the flat portion of this graph represent? Well, we see that here, this flat portion is here, means the distance is staying the same. In this case, he's constant distance Okay, so the distance isn't changing, it's a constant distance. Or we can say staying still. The person is staying still there. Okay, and this says, why does the graph never go down? Well, the total distance the person walks can never decrease. Because total distance is a distance once you're moving, and then that's your distance. You can't go any lower than that. All right. Flipping over to the next side. Okay, we're using this graph to answer the following questions. What's the graph showing? It's showing the temperature over the weekend. Okay, and we can see that by looking at the title and the labeling of the X and Y axes. Which day was the warmest? We don't know which day was the warmest. Maybe this is Friday, Saturday. Let's say it's Saturday. Okay. I don't know. I'm going to say that these are 2 days, just generally thinking about how days go, that it gets hottest and it cools down at night, and then it gets hottest and then cools down again. So I'm going to say the first day. Okay, I don't really know how you guys say it, whether it's Friday's your weekend or not. So I'm going to say Saturday. Reason that Saturday was the warmest. Okay, which season is being shown here? I don't know. There's not enough information. Again, we can't answer every question from the graph that we're given all the time. So there's not enough information. That's what NEI stands for in this case. Because all we have is 2 days. We don't even have how hot it is. Maybe if they told us that this was 110 degrees and this was 87, then we could say it's summer. But like, they don't even tell us that. Alright? Alright, so here we go. Looking at this graph, it says which scenario best fits the graph. So, in order to answer this, what we're going to do is we're going to make sure that we understand what they're measuring speed and over time, and the inline skating after school. So this says that Billy skates up a hill, maintains a speed for a while, then goes up a very small hill, only to quickly descend down a very steep hill. Then he goes to a small hill and finally comes back to the ground. Okay, that would make sense if this were measuring altitude. It's not, it's measuring speed. So this doesn't tell us anything about speed, so we know that A can't be it. Billy slows down as he goes up a hill, maintains a constant speed for a while, slows a little bit more, and then races downhill very quickly. He slows as he goes up another hill and finally comes down to a stop. Alright, now here's the issue. It says he slows down. What's happening to his speed? It's increasing. So it can't slow down. It has to be going faster. So if any of these options are correct, C has to be correct, but let's make sure. Billy skates down a hill. Okay, so as he's skating down a hill, what's going to happen to his speed? It's going to increase. He maintains the speed for a while, then he picks up the speed before coming to a sudden stop. And he then increases the speed again for a constant while, and then slowly comes to a stop. That makes the most sense. Okay, by elimination and just by itself, it makes the most sense. Alright, sketch 2 graphs of the top thrill dragster at Cedar Point. The first should show the speed of the dragster car over time, while the second should show the height of the dragster car over time. Bring that into me. Okay, sketch these 2 graphs. Make sure you label your vertical axis and your horizontal axis. Make sure you title them height and speed as well, or height of the dragster, speed of the dragster, and then I'll check those along with your notes. Alright, see you tomorrow.